MapReduce. We will see what is MapReduce and some example application, and we will talk a little bit about fault tolerance and also about other applications that use MapReduce, what it can be used for. So why do we focus on this MapReduce? That is a programming model that can be used on these clustered cloud environments, and it allows for easily programming these multiple computers to do some task. So it allows for easy parallel programming. So it basically has two functions. One function is the map function, and the other one is the reduce function. And that work together in a sequence. First the map works, it does something, and the reduce takes the output from the map and continues to perform another function and produce the final result. So there are these two steps. The reducer is optional. It can be used or it can be skipped. However, if you use that, it runs on this managed it can run on this managed distributed file system that I mentioned earlier, where we have the multiple computers and chunks of files are sitting on multiple computers. So it does invisible management of hardware and software failures, because the cluster itself in the back end has multiple copies of the files, and if something fails, it's going to go and find the backup of that piece and restore and assign a different machine to continue the computation. So very large scale data can be easily managed in this way, because we're going to take the data, no matter how large it is, and split it into small pieces and assign one piece to each computer to process. So that's what we can do with this MapReduce model. So the cluster itself, it works in a batch mode. Like these very old computers, the very first computers worked in batch mode. You create a job, you give it to the computer, it runs the first job. When it's done, it runs the second job. When it's done, it runs the third job. We can same situation here. It's a batch system, so it's going to create a job. If you issue this MapReduce job, it will start by collecting input elements of a single type. So the way this map function works is it has as an input, it takes two parameters, a key and a value. So that is called key-value pair. Let's say a key could be some documents. So that there is a Word document, and we want to search through this Word document and count the words, how many words it has, and how many times each word occurred in the document. But imagine this document is huge. Let's say much bigger than the laptop can handle. Right? So your laptop could be computing this for a couple of days. It is that big. And so we might have multiple documents like that we want to give at once and count the words in all these documents. So the key is the ID of the document, and the value is a specific word. So this will be given as an input to the function, and it will go and load all these documents and start counting the words in there. So it doesn't have to be documents and words. These could be cities and stores and the amounts of money that they generated, or something else. So I'm just giving an example. That is a function that you can write, and it is user written. Any logic of our choice can go into this function. But it takes these inputs, key and value pair, and applies the function to each element. And it says it applies this function in parallel. Which means if we give it like 25 documents, it will take all the documents at once, and it might send parts of them into each computer to process at the same time. So in parallel. So the mapper will apply the map function to a single element. There could be a mapper on each of the nodes, and if they're doing something similar, they could be grouped into a map task. It will create an output again of the key value type. So the output, it will say document ID 1 contains this word 1 300 times. For example, this output is then taken and given to a reduce function. So reduce function is the second function here. So the reduce function will take the output from the mapper function and will do something with it. Let's say it's gonna sort. Let's say it will sort all the words of the same type together and count. And so it's gonna give the final result to the user. So one reducer can take output from multiple mappers. Let's say each mapper did several different cities, but the reducer will pick up the ID, the city name, and take all the information for that particular city to reduce. So reducer will take output from the mappers to produce the final result. So you have these two functions like that. So the entire job is the union of what is produced by each reducer. So again, the reason we have these multiple mappers and reducers is because the documents, we either had a lot of documents or the documents was huge, could not be done on one machine, and each one of these is running on a separate machine at the same time. So eventually they produce multiple outputs, and now we have to take these outputs, combine them together to give the answer to the user. And that's what the reduce function will do. The union of what was produced by all of these multiple mappers and reducers will be given as an end result to the user. So we have to combine all these multiple outputs together at the end. This is how it looks like. Get the input. Let's say these are different documents. This is document 1, document 2, document 3, document 4, the map function. It's going to do something with them. So key value. Let's say this is document 1, word 1, and then multiple mappers might produce a result that is taken by a single reducer. So this reducer is taking output from this mapper and this one and that one, because it has to combine the results together to give the end result to the user. But it is combining them by using a key value pair that was produced from the mapper. Let's show another picture here. Let's say output is a document with words. And it's a bunch of words: deer, beer, river, car, something else. First thing we're gonna do is divide this document into pieces. Each one is given to a separate machine to process. So the first line goes here. The next line of the document goes here. The next line goes here. And now a map function is going to work on this part of the table. So what is it going to do? Take a key value pair. Key in this case is the word, and value is the number of times it occurred. So this is going to say deer 1 time in this text. Deer occur 1 time. River occur 1 time. Write this down. All the other mappers is going to do the same thing. Now the reducers will take outputs from multiple mappers and combine together. So we have this phase here, which can be either shuffling or ordering, and all of the ones that have a specific word, let's say there is bear here and another bear here. All of the bears will go up here. All the bears are here. Or if these are different cities, the same city will be here, the next city, and the next. And so these are processed by the reducer. So reducer will see bear occurred once in some document and occurred once in some other document, and add these counts together. All together it happened 2 times. So a reducer will do that. And a reducer can be running on multiple machines. Each one of these is on a different computer. And finally, a result from all these has to be combined together to give to the user. Because remember, the user doesn't know. We're doing this on multiple computers and we're splitting it into pieces. Let's say you log into Facebook and you want to search something in all of the posts of your friends. It's a huge text document that Facebook has to search through. Millions of people is typing stuff all the time. So they need these multiple machines to do this processing, and they don't do this, what I just showed you, in a batch job, in a huge cloud cluster environment. And the result that's going to be given to you at the end is combinational of all of these in a single result. Single list. So the final output is given here by the reducer in a single list. So this is what we just did. We have a large file. And counted, we counted. The document is a sequence of words, and counted the number of times that each distinct word is appeared in the file. This is what we did. This is a simple program to show how this was done. So the map function takes the key value pair. In this case, the key is the document ID, because we can have, let's say, multiple documents. And when you say text, this is a specific word of the text. So this is for each word. This is all the words in this case. the value is all of the word. So in this case, for each word in this text, produce the word and a number of times it occurred. The reducer will take this. So it will take a key and a list of values. And the reason you have list of values is because we combined these together, right? These same words were combined together. So it will have a list for all of the words that were of the same type. A word and a list of integers. So let's say the bear occurred once in one document, bear occurred once in another document. So you have a list of 2 bears. And so for each integer, increment. So bear happened once, twice, 3 times, increment, and produce the result. So this is the word, and this is the number of times that it occurred. And this is the final result from this. But that is a very simple program that shows what the MapReduce did in this word count. And we will do an example of this in one of our exercises in the next class or in the following class. I will give you an actual MapReduce word count program to run. But before you can run this program, you're gonna have to install some Hadoop system on your laptop, and also connect to our cluster so you can run it on the actual cluster. Because if you install the Hadoop environment on your laptop, you only have one laptop, right? And this requires multiple machines. You can run it in a single node mode, or log into our cluster and utilize the multiple machines. So we're gonna actually run this actual program, and you're gonna see how it runs in one of the exercises. Now, there are some tricks, there are some helpful functions such as combiner. Combiner allows for local summing of integers before it is given to the reducers, and that's what we have seen in the previous picture. We first shuffle or order, and we ordered the items, or we can use a combiner, which is a special helper function that can combine these integers before giving it to the reducers. If a task failed, so the whole job is process all of these documents, count the number of words. If one of the nodes failed, if one of the tasks failed, we can restart this particular task instead of resubmitting the entire job. So the outputs will not be used until the tasks are completed. So the reducers will not start processing until all of these mappers are finished. In this way, we are guaranteeing the integrity of the job. So if any map task failed, it will be restarted when we make sure all of them have completed. We are going to start the reducer part.